Does anybody in here actually work with SmartPlant? Apart from Corey? Nobody else? Well, I'm going to go show you a demonstration on SmartPlant later. What SmartPlant is, it's our design review tool. The reason I want to just show you it briefly right now is because I'm going to refer to it in some other documents. But basically, it's a 3D environment. It's an environment basically from all disciplines. We've got equipment who are designing the equipment. You can see the piping in there. You got the civils. You can see some underground. This is actually underground piping. But what we do is we take all the disciplines and we put it into a SmartPlant file. We actually generate this 3D environment, and from here we'll eventually go through with the client to actually review the plant layout. And this is where he'll actually give us comments and tell us if he's happy with what we've done or whether he wants to make us some changes. But I just wanted to show you, because I'm going to go through this a little bit more detail towards the end. But I just wanted to, so when I refer to SmartPlant, this is exactly what we're looking at. And you can basically, and I'll show you more detail. You can actually, if you were to build it out there in the field, we'd build it in here in a 3D environment exactly the same way. But I'll show you a little bit more about this later. So that is our design review tool. I'm sorry, PDS is our design review tool, and Bob Carboni is going to give you a class in 3 weeks' time, I think it is, and that's where you'll see the PDS, and we take the PDS to load into SmartPlant and make this design review environment. Yeah. Oh, that's not right, is it? One thing to do when we lay out is we have to understand equipment, the piping design layout. We have to basically take the major pieces of equipment, and there's understandings that we need to know. Let me just show you what we're having. I think you saw this during the vessel. I think the vessel guy showed you the same pictures as he told me. But what we do in this case here is part of our layout is we may have to consider something dressing this out. We'll have it fabricated like this. We'll have it dressed out in this area. You know, when we say dress out, what we do is we put the platforms, a hand railing on it. There may be some equipment on here, some level switches, some bridles. There may be some relief valves, even some piping which goes up and down on this. But one thing when we do a layout, we have to consider how we're going to get this equipment in place. And it may be positioning of cranes as positioning the equipment, and that could set how we actually how we actually get the how we lay out the plant. We do have to consider the construction aspect of it as well. Yeah, you see I'm lifting that. See, in this case here, we have to consider positions of 2 cranes rather than just the one. This is just giving an example of a drum. Sort of thing the client will be looking at is here, access to some of the manways. We've got some bridles on here. He wants access to some of this. He's looking at access to some of the piping control valves up here. We do have an egress over here. These are some of the things that the client will be looking at when we... And these are extracts from the SmartPlant design. Here's just another example. The vessel group designed the vessels. The piping group lays out the vessels. The vessel group will determine the size of the nozzles, the internal trays, the thickness, there may be a process requirement, the head height. They will take care of all of that. The piping group will determine the orientation of the nozzles, locations of the platforms, access for the ladders, access to the sight glasses, access to the transmitters, and we will get involved in also the maintenance side of removing the equipment. Okay. The layout of vessels within a unit's complex shall be such that a similar orientation are used for ladders, instrumentation, manholes, etc., and that an effort has been made to gain uniformity in arrangements of vessels' components. When you operate a unit, you don't want each vessel, each tower to be different. You like them all to be the same. The sort of thing we look at, we want from a manway down to the platform to be the same. We want ladders to be on the same side. You want with this, basic shape and configuration for access components to be identical. Ladder and platform requirements indicated shall be in accordance with OSHA requirements. Ladder and platform access for operations and maintenance shall be provided for manholes, valves, instruments, etc. Ladders are generally a prime means of access to the platforms. Occasionally a client may specify stairs or additional access from a joining structure. It's quite common actually that this is not really, but if we had a platform here and we had this platform here, a lot of times he'd like us to extend this platform out just so he can go from this platform onto that platform. It's not a requirement, it's usually just a client's preference, and when we get into the model reviews, they're the sort of things they like to tell us. If they like them, they just don't like to pay for them. When the same ladder, when we do our design, platforms may be combined when practical. Adjacent platforms may have common elevations for access for each other. These arrangements must be checked for a vessel expansion differential, wind sway, a 3 inch minimum gap and a 3 inch minimum gap and a maximum gap to suit movement conditions required. Each structure, each vessel just moves. It has a different expansion configuration, and it just has to be considered that way. It says on the vessel, when we have the same ladder access to 2 platforms, the differential in elevation must be increments of 1 foot. Most of our clients prefer more than 1 foot, usually 3 feet. What that is basically saying is that if we have a ladder coming up a vessel here, it says this platform here and that platform there cannot be, this is saying 1 foot. In this case, our client was CNRL. They had a specification to say that this platform and that platform could not be any closer than 3 feet. The reason they do that is if this platform was here, the operators would open a safety gate from the cage and they would jump across. But if you have a 3 feet separation, it forces them to get on a ladder, go up a couple of rungs, then get off onto the next platform. Otherwise, there's a big hole down here, and they see it's been an unsafe act. So, and that affects a lot of times the nozzle locations and instrument locations to make sure the platforms work.
So can you put that into the smart plan, and then, or do you just manually draw it and then someone checks that?
Yeah. No. What we do is we do orientations on paper, and that's early on in the stage, and then we will build it into the PDS, and then we'll put it into the smart plan right here, and we'll send it for client review, and also the vessel review. We usually send it for the vessel review first, and then we'll build it into the models. We usually it's kind of cumbersome because if you change one nozzle, the whole platform configuration can be thrown out. For example, if they decide to take this nozzle here and drop it down by say 18 inches, that platform's wiped out. I can't put it here, so all this platform's wiped out. There's a lot of design work, a lot of juggling going into the layout on getting the platforms and ladders right. We will only let our senior piping guys look at it, otherwise we'll get into lots of problems. Manholes are provided for access and inspection to vessel internals, trays, and internal piping. Manholes located shall be noted on individual vessel drawings and the process data sheets. Manhole orientation depends on tray, arrangement access, and maintenance shall generally be located to the rear of the vessel. What you don't see inside this vessel, there's a lot of internal trays, and these nozzles have to be located in a certain design with the trays. If that tray changes position, also that nozzle has to position. So we have to consider the internal trays to make sure we don't clash with the trays inside. A lot of these, they do have internal distribution pipes to make sure we get even distributions that hits the trays and cascades down to get even flows. It won't be here, it'll be on the nozzle, it'll be on the top nozzle. And also what it was saying is that it has to have the manways on the access side. What this is the road. You don't see it here, you'll see it later, but this is the road side on here. If there's a problem over here, if there's a leakage or there's a fire over here, we don't want you to come out the manway on the problem side. So we're always locating the manways away from the pipe rack, away from the equipment side. So we'll consider that during our vessel layouts.
You can't tell where the trays are. I mean,
No.
this, how do you...
We have to get that from the vessel group. And a lot of times we will try to, early on we will try to second guess them through preliminary information, and we'll try to work with the vendors to make it work. That's one of the, it is a problem sometimes because a lot of it doesn't come through till we get a PO and purchase agreement with a vendor, then he starts doing his design and we're trying to continue with our work. But we have to work closely with our vessel group on what their recommendations are for our internal tray design.
We don't design the internal packing?
No, we don't.
Yes, right?
No, we don't. All we do is that when we do our layout, we'll send it to the vessel group, and they'll just verify the design based on the internal trays. There's certain other requirements, such as when you cascade down, you got wet zones, you got dry zones. Some of the, where it cascades down, you got areas which are open to the vapor. Sometimes we want to read temperatures in there, so we have to locate thermal wells in that area. So we have to work out with the spacing of the trays and where the trays are designed to make sure we put those thermal wells in the right location. Then we have to make sure we have access from a ladder. And one biggest problem that people do is that if we put say a thermal well here, you can't get off the ladder. So we've got to make sure that it's leaving clear off the ladder, but still accessible from a ladder.
When you do a revamp project, do they give you like a smart plan sketch? Or is that something that...
No, we have a new system right now. I can't remember what it's called. It's called LFM.
Viewer, maybe?
This is basically we take it to the field and we scan the area, and from that scan we can now put the revamp stuff into this sort of environment. I think the Chevron project is using that. This is basically for the new side. But I mean, we could still. This what I've got in here doesn't really show it to you, but on the BP we do actually kind of build a lot of the existing facilities, and we show it in a different colour, and then we show the new piping as against them.
Yeah, that 3D imaging scan they do almost looks like a photograph.
Yeah, I believe it's very good. Yeah, rude.
They have a guy who just goes around, or groups of guys who go around the plant in all these different spots, and they just set up a little camera with a laser scanning machine, and it just does a 360 scan around it, and they move it, move it.
Okay. Yeah, sort of things that we have to also consider when we do our layouts is ladders. Maximum we can go is 30 feet. So after 30 feet, we have to break the ladder, have a rest platform. Otherwise we can't go from the top to the up here. We have to have every 30 feet a rest platform, then go up 30 feet another rest platform. Problems we always have is that if we do have equipment here and we have this platform, sometimes we get knee braces which are not shown here, and if you walk around there could be access problems. We do put davits at the top of these vessels that have internal trays, or we do have valving at the top, which allows us to remove equipment down. I'll go into that a bit more later. Also, we have to consider on these that each column has to be maintained. Manways have to be opened. So what we have to do is basically take utility stations. We have to put an air station at each manway, and that allows them to maintain it for pneumatic equipment. We will look at the when we position this in the vertical, this column, we'll look at the process documents, and a lot of times there may be a non-pocket requirement in some of this piping down here, some of the outlet piping, the drain piping. If there's not, then piping group will set this elevation, and it's usually just based on head height. So if we have piping coming across here from this drain nozzle, we'll just set this height by 7'6", and that allows us to walk under that way. If it's not a process requirement, then piping group will set it. In that position there. When we do our layout on the vessels, we have to consider manways. We've got swing hinges here. We've got to open the manways. We've got to make sure it doesn't hit the hand railing. We have a minimum requirement of 120 degrees. A lot of times the client will prefer a lot more than 120. He'd like it to be open all the way, if possible. When we have side steps from one ladder to another ladder, we've got to make sure that there's nothing in the way here, and we've got a minimum of 1 foot landing here for him to stand on and pull over to the side. We're going to make sure when he side steps that he goes all the way across here is clear. The client does not like step-through ladders. He always prefers side steps. It's easier to grab hold of a ladder and side step because you can see where you're going. Whereas if you're actually if you're going a step-through ladder, it's easy to step through, but it's difficult to step backwards. So it's it's very difficult for. The operators will not usually accept step-through ladders on a vessel. We do sometimes get a waiver on the top platform. We have to consider access in front of these manways. If we do have trays inside them, we do have a minimum of 3 feet. Sometimes they may prefer a little bit more than 3 feet in front of, say, a manway into the vessel. Some of the clients prefers to have several feet sideways as well. That allows him to put some tools and equipment there. But again, if we make these platforms too wide, they get knee braced underneath, and that knee brace causes access problems. It's all part of a layout design consideration. This is an air station right here. It's usually very debatable, the location. It's basically good so we can set, if you're going to go inside here, there may be trays which may be bolted. They're going to have to run an airline in here. They may have some pneumatic equipment they're going to have to operate. So we will locate a utility station, as I was saying before. We won't cut it into the platform here because it may hinder the guy who's just normally walking up and in doing some inspection or maintenance. I don't really like this location because when you locate a utility station, you've got to consider there's going to be a hose on the end of it. That hose are going to be coiled and put on the floor. And if it's right here, then if you're going from this ladder to this ladder, this hose could be a tripping hazard for the maintenance guys. This would be a much better position for it. Then they could just run the hose around here, all in this position. One thing we'll look at is that we may have valving at the top of the platform or internal trays. We will have to put a davit at the top, and it's just basically to remove any equipment, and we will have to make sure there's a free space down to grade so that it can be removed. We have to make sure that sometimes we can put this too close to the manway. So when it actually swings, the pickup point is too far away from the platform. So we have to locate this davit arm so that it actually swings to maybe where the manways are. And that's another reason that we have all the manways lined up, so that this pick point on the davit picks up from all the manways. Otherwise, we have to pull it out of the manway, we have to drag it to the side and go to the pick point on the davit. So that's usually, when we do our reviews with a client, that's one of the things they certainly look at. And I say if they can make a simple comment, that simple comment can wipe out a design of a vessel very quickly, very easily. On page 58, I don't know if I've got it on here. 58 just shows some of the equipment we have to consider for access. So I mean, that's just, it's the same as the instrument bridles, manways, thermocouples. Yeah, this is an old standard. That's all. This came out of a Worley Parsons website. Yeah. We have to consider going up a ladder, allowing them 2'6" clearance from any piping or cable trays. A real contention is when you're climbing the ladder here is not having tripping hazards for your foot. If you do what this is showing is a reinforcement on the vessel, and it's showing insulation around it. This is quite easily be a tripping hazard if somebody, you kick while you're going up high. They do allow us to put it in the top section between that rung and this rung, but the client wouldn't like that anyway. And usually when we do some field routing of, say, some conduits, but the conduits sometimes can be run in positions behind it, which could cause tripping hazards. But there'll be things that will be reviewed by the inspectors in the field. This is just basically showing again what I was saying about the manways. You want the davits, you can see the pick point about here. You can see the dotted line. You just take out the trays or anything which is coming out, and as soon as it picks it up, then we need an area which will be cleared down to grade, and they'll just drop whether it's trays or valves. Usually, the piping group will again work with the vessel group to see what's the heaviest component, whether it's going to be one of our valves or whether it be one of our trays, and from there we'll then design this davit arm based on the H and A dimension to make sure it picks up the heaviest component. Vessels are usually more tricky equipment to lay out. This is just showing some plate exchanges on a structure. I'll show some of the details. Here, this head end here is pulled off. It'll be unbolted here and pulled out here. This takes a large crane to do this. It will take a bed with a motor on it. A bed is just, when they pull this off, they'll put it underneath here. They'll attach it. They'll use spreader flanges to break the flanges apart. Then they'll bring in like a bed with a motor which will pull out the tubes. It'll be on the crane to drop it to grade. This shows a better details of the heads which had to be pulled. We'll keep these heads on the maintenance side, and here you can see that we have breakout flanges right here. There's a flange here where we can disconnect this piping spool and take it out, and these can then be pulled into the maintenance area. If these are insulated, we'll tend to put lifting lugs or lifting brackets on them. Just another view. This is basically just showing what I was saying before with the plant layout. If we got a lot of these exchanges here, we like to keep it a uniform design. We'll just line up over nozzles, over shell nozzles. We'll try and keep it uniform and take some of the piping back behind the flanges. And if we do have a structure, this is showing a structure to support the piping over the plate exchanges, and here it's just showing them lining up with a pipe rack column line, and that just keeps it uniform. And here this then allows us to actually go ahead and take this piping towards the pipe rack, which is on this side right here. If we do have a shell head, which is on the back end of exchanges to be pulled, they do prefer to keep it clear overhead so they can pick it up with a crane or another piece of component. And here you can see if we do run a line over it, can leave 12 feet below that line for picking up the components. And here we're just showing 3 feet, I'd say, clear access between the components. We have to consider the supports for this. When we line up the shell heads here, we also have to consider the supports for the exchanger, and we'll try to line these up as well if it's feasible. We do have nozzles on the bottom, and we have to clear those nozzles as well, and that may prevent us from lining them up. So sometimes we may have to stagger them, but we'll try and line up the foundation, and we're trying to line up the shell nozzles if possible. And if we'll have the support to keep the same foundation, we'll put that support in the same location as the foundation. That way we don't have to put 2 foundations down to support the steel. Again, setting this elevation. If the process documents don't set this elevation, piping group will set the elevation of the equipment. Basically, if we got nozzles on the bottom here, we'll just put a 1-inch drain on here. We'll leave 12 inches below that drain. That'll set that elevation to that pipe, and then we'll just work out this, and then we'll set that equipment and put it on our equipment location drawing. And again, this is just showing the shell head on the back end. It has coils inside here, So sometimes we may just take this head off here to inspect the back end of the coils. But these heads can be quite heavy and cumbersome, so we've got to leave it clear. This is showing a divot on the back end. We don't tend to do this. The reason we don't tend to do it is if we swing out, it takes up too much space, too much access. It's easy just to leave it clear for maintenance with a crane. We don't take these heads off very often, maybe every turnaround, every 3 or 4 years. We do have a requirement sometimes to stack exchangers. If one exchanger doesn't give enough cooling, we may have to stack them to have a double of a requirement. And we just have considerations of keeping it below 12 feet. If we keep it below 12 feet, we don't need to put a structure. If it gets too big, we're looking to put them in the structure. Just money and cost and doing this. If we do put exchangers into a structure, we've got to consider, because they're not so accessible, we have to consider monorails, we have to consider drop areas. When they open up some of these heads, they may have some residue fluids in there. There may be concerns on some spillages, maybe small amounts. We may have to consider some form of drip pan or drip tray, draining it down to grade. We'll consider that as part of our layout, part of our design. And so where if we pull the shell tubes out here, we're going to just an open area, and that will just drop down to grade, where it'll be on a flatbed and pulled away by a truck. Usually the shells go from here right to the back end of the body, and we'll usually allow from here to here, maybe 1.5 times the shell length. One of the other equipment we have to consider for layout is air coolers. This shows it down at grade, but a lot of times we'll just take these air coolers and we'll just stick them on top of the pipe rack. We have steel there for, and it's a good place for them. And there's usually, from a spacing point of view, to put that on top of a pipe rack, this air cooler, it's usually commercially the best place to put it. This is just taken from Alaska, that's why it's got the snow. This is on the GC2 plant up there. A lot of things we'll be looking at here is that inside this body here there's a lot of coils. The coils do get plugged up. We will have to take these little plugs off, and we have to kind of just rod them out like little chimney brushes, but they can be long. We have to build a platform all the way across the end here. We do have to keep the handrail below what we call the head here, and that allows us to clean out all this side. They do prefer to have it on both sides, but it really only required on one side. They'll just put a bucket on here, and as we push it through, it'll clean. They'll put a bucket here to catch any residue out on that side. We have to design the platforms below it. Underneath here, we do have fan motors. We are looking at layouts of the platforms below here to maintain the motors below these fans right here. It just takes it's just for basically a cooler. It just takes the air from above here and just takes it through. It just comes through here through the coils, and we got process pipe in here, which will help cool. This is just showing the layout of the platforms to the motors. We have to consider. These are the platforms on the side right here. And I'd say on top of the pipe rack, as it's shown here, is usually the optimum position for it. We do have to consider when we work with the vendors. The nozzles on here are usually just made of very thin plate, and they're not actually round. They are actually like an oval shape, and they're very weak. We do have to consider how we support on here, and we do have to coordinate with the vendor early on to make sure it's supported properly. Our heaters, our fired heaters. We don't get involved, Piping Group, too much in the layout of a lot of this platforms. A lot of it's already pre-designed by our vendors. but we will get involved in in reviews, and certain things we have to consider is on the convection section and the radiant section. Convection section, we do have coils which have to be removed out of this. You can see the height of it, the concern on the height. Of course, you're going to have to consider a crane location for accessing to these coils here. This is actually for construction, but we would actually, as part of our layout, we would position a crane and besides a crane. A lot of this time, the client will recommend a size of a crane unit, which we'd have to consider for the positioning for access to some of this equipment. This is another view of the convection section. This layout here is just showing the area required. This is just a pull area for coils coming out here, but say the pull area is not the problem. It's position of the crane to access it, to pull it out, and that'll be part of where we'll try to position it to maintain this equipment.